Welcome back to my lecture on probability and statistics, and in this section we're going to be focusing on what is a probability function. So the first thing we have to understand is a sample space. So we've talked about sample spaces before, and we've given a couple examples of them, so I'm going to assume that we understand what that is. And then the next thing we're going to do is we're going to define a sigma algebra that we're going to denote as capital B. Okay? And we're going to define the sigma algebra first. So a sigma algebra is a collection of subsets of S. So B is a collection of, that is the worst F I've made, subsets of S. Now, this collection satisfies three properties so this is with three properties. Okay, the first property is that the null set is an element of the sigma algebra. The second property is that if you have some event denoted A, so A is an event in S, your sample space. If A is in the collection of subsets of S, so A is in the sigma algebra, that implies that the complement of A must also be in the collection. Now, there are subsets of your sample space where this may not be true, but for this special collection called a sigma algebra, this must be true, okay? And then third, if you have an infinite number of events in your sample space, we'll call them A1, A2, all the way infinitely, are in B, then this must imply that the union of all of them must also be in the sigma algebra. Okay, let's look at an example of what this means. So let's bring an example. I have 2 red marbles, 3 green, and 1 yellow. My sample space, S, is equal to red, red, green, 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 yellow. Okay? My Borel set, shouldn't have called it that, but that's what it is. Borel field, or sigma algebra, must be such that if red is in my algebra, then not red, which is equal to 3 green and a yellow, must also be in that set, in that collection of subsets. Because as you can see here, green, 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 yellow is clearly a subset of S. Right here, so this portion, let's grab a different color, this portion is equal to this set, or I should say is a subset, but yeah, I'll use the equal symbol. So this would mean that I could calculate the probability of red, I could calculate the probability of not red. And we're going to figure out how to do that in the next section.